Hey guys, I hope you're having a good day. I'm sorry I can't be with you, but I can't wait to be back there tomorrow. You're going to need your interactive notebook and these colored pens or pencils, and then we'll go ahead and get started. If you want to go ahead and update your table of contents, you can pause on this screen. I'll zoom in for you a little. You can pause right here. If not, then you can go ahead and move. Third period, you guys are going to need to go to page 52 and copy what I have. Fourth, fifth, and sixth, you guys can go ahead and move to 53. If you were absent yesterday and you want to copy 52, you can do that. Anybody else that was absent, the work for 51 is in the 22 folder, along with bell ringers if you need an extra copy. So I'm going to turn to 52. Here's my work from 51. Obviously, I need to answer my passage, but I have until tomorrow, right? It's due on Thursday. All right. First period. Here is first, third, whatever you guys are. Here is page 52 for you. And then I'll let you go ahead and pause. Everybody else, go ahead and move on to 53. So I'm going to make sure my page is numbered down here at the bottom, 53, and we'll go ahead and get started. So at the top of your page, you need to make sure that you have labeled your page types of ocean currents. See if we can't make this a little clearer for y'all. How about that? Okay, first current. We're going to put a bullet point here, and we're going to write surface currents. All right, we have a couple different things we need to write down about surface currents so that we have all the details. Most of this should be review for you guys because this is not the first time we've dealt with information on currents. So first up, surface currents occur near the surface of the ocean. Duh. Second detail is that wind makes the warm water move across the surface. All right, and your last detail is that winds are able to move the top 400 meters of the ocean. Remember how much a meter is, and then think about 400 times that. Because I know for my brain that is really wild to think about. 400 meters is a lot. All right. So we're going to draw a quick picture. I will tell you ahead of time that you were going to have more information to put down here. So I suggest leaving some space down here towards the bottom for deep currents. All right, so right here we're going to start by drawing kind of a slant that goes down. Okay, we're going to label this over here as our coastline. Okay, which would mean that that right there is actually land or sand. So I'm going to take my color pencil and just shade it in so that I know it's not water. Doesn't have to be anything beautiful, just so you know what it is. That doesn't look very dark. I promise you can tell in my notebook. All right, so that's shaded. Obviously, we have to add water. So we're going to add the water coming right up to the coastline in waves. And now we need to make a few more additions. So I'm going to add arrows that are kind of following the flow of the coastline here. These arrows are wind. Okay, out here we have our ocean. That's my husband. If you heard that chime. Alright, so I've colored my water. And then we're going to take our red and we are going to put some arrows right here that show the flow of the nutrients in the ocean. Just kind of an important thing to keep in mind, that all of that's kind of getting stirred up. So we're going to label it nutrients. All right, if you need to pause, you're welcome to. If not, we're going to roll on down to the bottom. All right, deep currents right here. Important information about deep currents. They form below the surface of the ocean, obvi. They are controlled by the density differences in the water. If I was with you guys, I would ask you what makes up density. And hopefully you would know the answer. Okay, so temperature plus salinity equals density. We know that the colder and the saltier the water, the heavier it is. So this time our picture's gonna look quite a bit different. So right here, you're gonna draw a wiggly line. We're gonna label this ocean floor. Okay, I'm gonna take my brown. That obviously doesn't show up. Maybe that's appropriate. It looks more like sand this way. Okay. Then we're going to take our water and draw our water in here. Okay. What is happening? Oh no. Alright. Lovely blue ocean. Again, doesn't have to be beautiful, just has to be obvious what it is. Alright, now I'm going to take my blue, my dark blue, and I'm going to draw some arrows down here. Alright, and then, let's do one more. I'm going to draw some arrows up here. And hopefully you know that this is a convection cell right here. This is a question I feel like I've asked y'all like 100 times, and it's always a Jolly Rancher question. Maybe be prepared for that when I'm back tomorrow. So this singular unit of temperature change, the warm water getting heated at the surface and then falling down as it cools, the cold water rising up as the warm water moves down and replaces it. That is a convection cell. Obviously, this is our ocean. You probably don't have to write it, but you know. Okay, pause if you need to finish. If not, go ahead to 54. All right, on 54, we have our last type of current, and then you get to move on to your web quest. So we are going to put convection currents at the top of this page. Sorry, I'm on all kinds of markers. All right. Convection. Convection currents. All right, first detail is cool, dense water sinks to the bottom. Cool, dense water sinks to the bottom. All right, dense equals heavier. All right, and water becomes more dense when it is cold because the molecules, that's the stuff that makes up the water, are closer together. All right. Then we have hot, less dense water rises. Okay, so we're putting as the water heats up, the molecules spread out. All right. Now, this is our easiest picture yet. You don't even have to draw the ocean floor. So, we're going to draw our water. Okay, I'm going to take my blue so that we know that this is happening in water. Yes, this is necessary. Yes, you have to do it. Water. I did color outside the water, y'all. Okay, lovely water here. So now I'm going to draw my convection cell. Okay, so I'm actually going to turn my notebook because it's easier for my brain this way. Okay, again, I'm using my blue on this side. And then on this side, I'm going to use my red. Oh, man. Well, it's not perfect, y'all. Okay. Ooh. It's kind of rough looking. That's okay. Okay. We need to write on this side, cool water sinks. On this side, warm water rises. Ooh. Okay, so as long as you understand this concept, you should do okay. Because as the water towards the surface starts to cool off, it'll start to sink towards the bottom. Okay, and then you have a nice layer of cold water, the coldest water at the bottom. So the water that's a little bit further up will warm and rise to the top, where it gets really warm, and then it cools down. And it moves in a cycle. Okay, this is called what? I hope you all just said it out loud in class. I would give you a sticker. Alright, so this right here is convection. Okay, one isolated instance is a convection cell. Okay, so right here you have a single convection cell. Alright, that is all I have for you today. I miss you guys and I love you, and I will be back tomorrow. You may go and show Miss Murr, I believe she's your sub today, your completed notes. She's going to be checking to make sure that they have color, and then she will give you your sheet for your web quest, okay? At that point, you may go ahead and start. Let's see. I was going to show you guys my cat. If you're still paying attention. That's her. She's upside down. Hey, Days. Days. Say hi. Oh, that's very cute. Oh. That's my cat, guys. And that's my husband. Hey. Oh, that's his socks with pancakes. I can't find his face. Anyway, love you guys. Bye.